In this video, I am going to solve this initial value problem using Laplace transform. The differential equation is this: y double prime minus 5y prime plus 4y is equal to 0 with initial condition y of 0 is equal to 1 and y prime of 0 is equal to 2. Now, what we are going to do, we are going to apply Laplace transform to the given differential equation. So, Laplace transform of y double prime minus 5 y prime plus 4y and Laplace transform of 0. Now, you know Laplace transform is a linear operator. What it means that we could break these things into pieces. So we could write it as Laplace transform of y double prime minus 5 times Laplace transform of y prime plus 4 times Laplace transform of y is equal to 0, because Laplace transform of 0 is 0, which tells that the function is 0, right? So that means the integral that defines Laplace transform will become 0. So now, before I go to the next step, let me clarify something here. So this is kind of important. You need to know how to find the Laplace transform of y double prime. So Laplace transform of y double prime is going to be s square y of s minus s times y of 0 minus y prime of 0. Now let me clarify what I mean here. So I have introduced a new notation here, y of s. What is y of s? Okay. So let's say you have a function y, okay? You want to take a Laplace transform of it. So Laplace transform of y of t of s. This sometimes is denoted by y of s. So that's what it is. So this is important for you to remember. Laplace transform of y of t of s, right, is denoted by y of s. So that's what it is. And s is the constant, as you know. Now, Laplace transform of y double prime is s square y of s minus s times y of 0 the initial value, minus y prime of 0. So this is something you need to know in order to solve this. Now let me go ahead and give you Laplace transform of y prime. Okay, Laplace transform of y prime instead of y double prime. That is going to be s, since there is single prime, okay, s times y of s minus y of 0. Now, I'll give you another example, even though we do not need it for this problem. Laplace transform of y triple prime. I'm giving it here so that you can get a feel for it. It is going to be s cubed, because triple prime, times y of s minus y of 0, minus s squared times y of 0 minus s times y prime of 0 minus y double prime of 0. So you can see the structure, okay? You start with the highest power of s and then you gradually go down. In our case, we need the Laplace transform of y double prime and Laplace transform of y prime. Now, I'm going to go back here, okay? And I'm going to get these values. So from the first one, I'm going to get s squared times y of s minus s times y of 0 minus y prime of 0. That's what it is. Then next one is going to be negative 5 times s times y of s, so which is this. Then negative and negative is going to make it positive, plus 5 times y of 0. Okay. And then plus 4 times y of s, because Laplace transform of y is denoted by y of s. uppercase y of s. This is just a convention for convenience purposes, okay? So all of this is equal to 0. Now what I'm going to do, I'm going to plug in the values. So let's combine the y, all the terms that have y of s in it. So it's going to be s squared, then minus 5s plus 4. Actually, yeah, plus 4 right here. Plus 4 times y of s, then s times y of 0, but y of 0 is 1, so it's going to be negative s, then y prime of 0 is y prime of 0 is 2, right? So negative 2, then plus 5 times y of 0 is 1, and all of it is equal to 0. So if I simplify it, I get y of s is equal to s minus 3 over s square minus 5s plus 4. Now if I factor it, I'm going to get s minus 1 times s minus 4. And I trust that you can do it, how to factor this s square minus 5s plus 4. Now this, by the way, this right side, I'm going to break it down into two pieces by partial fraction. So s minus 3 over s minus 1 times s minus 4. Using partial fraction, I could write it as a over s minus 1 plus b over s minus 4. Now I'm going to multiply both sides of this equation by s minus 1 times s minus 4. That's going to give me s minus 3 on the left, and on the right is going to give me a times s minus 4 plus b times s minus 1. Now if I simplify it a little bit further, I'm going to get s minus 3 is equal to a plus b parenthesis times s, then plus negative 4a minus b. Now this, by the way, is an equation. So what you can do, you can compare the coefficients on both sides. So coefficient of s on the right is a plus b, coefficient of s on the left is 1. So that gives us a plus b must be equal to 1. Now constant on the right is negative 4a minus b, and constant on the left is negative 3. So it must be the case that these two are equal. So if I just multiply everything by negative 1, that's going to make it positive. So it's going to be 4a plus b is equal to 3. Now from this one, I could solve for b. If I solve for b, that's going to give me 1 minus a. So 4a plus 1 minus a is equal to 3, or 3a is equal to 2, or a is equal to 2/3. Okay? If a is 2/3, I can plug it in here. A plus b is equal to 1. That gives me b is equal to 1/3. Now I can take this guy, okay, and then plug it in. So my y of s in that case is going to be equal to 2/3, okay, over s minus 1 plus 1/3 over s minus 4. Now this is what we are going to get. Now at this point, what we are going to do, we are going to apply the inverse of Laplace transform, or inverse Laplace transform. So what Laplace transform does to a function, inverse Laplace transform is going to just reverse the process. We applied the Laplace transform to the initial differential equation, right? And we did some work, we simplified it. We came up with a simpler solution by applying the integral transform, which is the Laplace transform. Now we want to go back, because by applying the transform, we actually changed the function in a way. We have taken it from one space to another space, okay? It was in one space, we took it to another space. Now we get to come back, or we got to come back to our original space where the function resided, okay? So we do so by applying inverse of Laplace transform. So inverse of Laplace transform of y of s, which is going to just give me y or y of t in our case. Inverse of Laplace transform of 2/3 over s minus 1. Remember, Laplace transform is linear, right? Inverse of Laplace transform of 1/3 over s minus 4. Okay, now this is going to give me y of t, okay, because this is the one for which we took the Laplace transform. Now this is a constant 2/3, I can bring it outside. So inverse Laplace transform of 1 over s minus 1 is going to be nothing but e to the power t. All right, then plus inverse Laplace transform of 1/3 over s minus 4. 1/3, I can take it outside. S minus 1 over s minus 4 is going to be e to the power 4t. So now, by doing this, we actually found the solution to the original differential equation with given initial conditions. So this is rather relatively easy way of solving ordinary differential equations. So my solution is right here. I hope that this discussion was helpful. Thank you very much.